questioning is perhaps the greatest gift we have as human beings.
Science is more than a body of knowledge. It's a way of thinking.
It's a way of thinking that teaches us to question everything we think we know.
Science came about by developing techniques, methodologies for gaining reliable knowledge about the world.
We have at our fingertips the technologies that were only possible for the largest governments and corporations 20 years ago as an individual today.
If the human civilization continued at anything remotely like the current pace of technology advancement for 1 million years, where would we be? I think we're either extinct or on a lot of planets.
The good thing about science is that it's true whether or not you believe in it.
We hold the scientific method in high regard because it works. If it stopped working, we throw it out.
Discover the past.
Create the future.
This is the Here and How podcast.
Welcome to the Here and How podcast, where every week we dive deep into big ideas to explore the past and create a brighter future. This is episode 23, Did the Universe Come From Nothing? I'm Stephen Woodford, also known as Rationality Rules, and with me is the tremendous Thomas Westbrook, also known as Holy Kool-Aid, and the radiant Rachel Oates. Say hi, guys.
Hey.
Hi, guys.
How are you both doing? It's been a while.
Yeah,
Good.
Had a little break. It's quite nice, wasn't it?
Yes, refueled and ready to podcast again.
I want to say to our listeners, we're sorry that we've had given you guys a, I guess, 2-week break from the show.
I'm not sorry. So let's get into this episode. I recently debated Blake Jonter, who is a Christian apologist, on the Unbelievable show. That will be released about the 18th. And we debated the Kalam cosmological argument, and one of our biggest disagreements came down to how to interpret the current cosmological evidence that we have. He believes, like many, that we now know that the universe began to exist out of nothing, while I, and many others, don't think that's the case. I understand that you guys, being super fans of my content, may have seen my most recent thoughts on this, but what are your current thoughts? Do you actually believe the universe began to exist? What are your thoughts?
Well, as much as I love you, don't hate me, but I've not seen your recent video yet.
Rachel!
I'm sorry. No, I'm really bad. We've been on a Doctor Who binge, so that's where most of my watch time has gone recently. But
that's more important.
It is, obviously. But I don't think I quite know enough to have a full opinion yet. But one of the theories that I do like is the one that says, I don't know in technical terms, but it's kind of this idea of the universe constantly expanding and contracting. So, some people think that once, because the universe is expanding now, some people think that once it gets to a certain point, there'll be kind of like a big crunch potentially, or it'll start. What's the opposite of expanding? It's like contracting.
Imploding?
Or
Deflating,
imploding.
Contracting?
Yeah. But some people think that might happen again, and then once it gets small, it'll start again, and so on. And I kind of think that there's potential of it being some kind of cycle like that, but I'm very, very open to new evidence and being proven wrong or whatever. So
it's funny because it's good to have somebody, listening who's not too much sided in any area, who's open to the evidence, and who perhaps it's not a topic that you generally care about. Maybe that's entirely possible. I don't want to put words in your mouth, but I find myself being like that on others, which is a question that will come up later on as well.
Yeah, I wouldn't say I'm not interested in it. I just, physics isn't my strongest area, so it's not something I've ever looked into in, that much detail.
No, well, fair play. There's loads of different hypotheses, so many more than I expected when I started looking into this topic. But the one that everybody knows is the Big Bang because it's the currently accepted, and there's really good reason for that. One of them was what you were saying, where you have imploding. You also have lots of concepts to do with multiverses, and there's evidence for those. But of all the discoveries we've made, and we're going to cover what I think are the primary in this video, what ones do you both know of?
So there's one theory, and I hope I'm not butchering this, but I read it in one of Stephen Hawking's books that talks about how we think of time in terms of just an arrow going one direction. But it's possible that the Big Bang, when it happened, that it occurred in both directions, into our future and into the past at the same time, because all time is we remember the past, but that doesn't necessarily mean that time is just one unidirectional. So if you think of time kind of like a river that's just like frozen in existence, and you're able to kind of take a slice out of it and like look at it and examine it, that's like our current present. But all time is like an increase of entropy. And if you trace that backwards and say like, well, what if we could remember the future, and we think about and conceptualize the past, and we're going in the opposite direction? Like, if things were flipped like that, our experience of time would be completely different, but time itself would still be going in two different directions, into the past and into the future. And maybe it's already occurred. Maybe you can step outside of space and time and observe everything that's ever happened and ever will happen. And here we kind of get into determinism and free will. But if you think of it that way, then it's like the universe is infinite and eternal in both directions. Like the Big Bang shot everything out into the future and also into the past in like the same direction, the same way, and it all kind of cancels itself out at like a particular point in time. But I don't know, I guess
something that blows my mind about things like what you've just said is that it utterly violates all of my intuitions. It completely destroys, almost to a comical extent, the way in which I look at the world. But the thing is that the most significant discoveries we've made in the last century have all been things that have done that, or at least most of them have. So quantum mechanics, that at this point we suspect very much is the case. However, that ends up being defined in its details. It really does shatter the way in which we experience things. Most things are comprised of nothing. That's not something that would ever come to us via intuition. It's a difficult thing to conceive. So all these theories, such as the one that you just mentioned, they sound bizarre, but when you look at the evidence that they're based on, these people, scientists, physicists, aren't people that just go into a pub and go, what about this? It's like it's always an inference on evidence, and if it's not, they are more often than not very open with the fact that it is just a hypothesis. So the story begins with the whole Big Bang, or the whole universe coming from nothing, the model that we currently accept, at least in my opinion, in 1912, when the American astronomer Vesto Slifer, which by the way is an incredibly cool name, who was using a spectrograph to investigate the rotation periods and compositions of planets, discovered that most of what they then called nebula, but we now call galaxies, are redshifting away from us, while other celestial bodies, such as what we now know as the Andromeda Galaxy, are blue shifting towards us. So unless you know what redshifting and blue shifting is, that might not mean anything, but it's an incredible discovery, and it means a hell of a lot. Do you guys happen to know what redshifting and blue shifting is?
Yeah.
Not well enough to describe it.
So I found a relatively good way of describing it, and that is because it is in essence the Doppler effect, which is an increase or decrease in the frequency of sound, light, and other waves as the source of the observer moves towards or far away from each other. So you may in the past have heard sirens in our podcast, courtesy of Rachel. As it gets closer, you can hear that it's closer, and the reason for that is because each time it emits a sound wave, it's closer, and so they bunch together and they hit you. Whereas as it goes away, each step it's further away, and so what you perceive as something intuitive, that you can just hear that something's coming, the same wave principle happens with light, and so things that are going away from us redshift, and things that are coming closer blue shift.
So
I think that's probably a good way of explaining
it. That's to do with kind of visible light being different wavelengths, right? Again, I don't know quite the correct terminology,
well,
but
it's not that the wavelength is different. It's that the waves themselves. Let me put it this way. So like if you hear like a siren coming towards you, right? There's a certain amount of space between like the sound waves, they're like a wave. It goes up and down and up and down, and there's a set distance between the high points. That's that is the frequency. How long does it take for each peak to hit you, each peak of the sound wave to hit you? And so if the ambulance is moving towards you, then in addition to all these sound waves traveling at the normal speed of sound, you also add to that the speed of the ambulance moving towards you, and so the peaks of the waves that come afterwards, like they're actually like moving in addition to the sound wave, and so like they're getting kind of crunched together. But then as it gets past you and it's moving away, then there's like longer, like it's the speed of sound minus the speed of the ambulance that's moving away from you, and so they get kind of stretched out a little bit.
Mm-hmm.
And so you at first you hear this wee 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 wee, it kind of it stretches it out depending on the direction that the ambulance is moving. Well, light kind of operates the same way. So if you have a star that is flying hundreds of millions of or hundreds of thousands of miles an hour away from you versus one that's traveling at the same rate towards you, because the light works kind of the same way, then you see that the frequency of the waves that are hitting your telescope they're either crunched together or stretched out a little bit. And so because we when we look at light, we put it in terms of like infrared, ultraviolet, the visible spectrum. We think of it in terms of like the colors that we're able to see, the range that we're able to see. And so we're like, it's either shifted towards the blue end or towards the red end, depending on the direction the stars are moving. Does that make sense?
Mm-hmm.
Yeah, it's a good explanation.
Yeah.
Cheers. That's better than I would have done. Before I move on to the second piece of evidence that we have, I've just got a few fun facts about Slifer. Again, such a cool name. I'm Stephen. How boring. In 1914, he discovered the rotation of spiral galaxies. So before then, people didn't know that they were spiraling. In fact, they didn't know they were galaxies, as I was saying. They just thought that they were a lump of or a coalition, if you will, of stars. But he also discovered in 1929 the sodium layer, which is evidently that there's particles of sodium all around the Earth's atmosphere, or certainly in certain levels of the atmosphere. Didn't even know that existed until I was looking him up. And he was also responsible for hiring Clyde Tombaugh and supervising the work that led to the discovery of Pluto in 1930. So they must have been very happy with that. Look, America's found a planet. But then another American says, no, you didn't.
Yeah, but he was wrong. Pluto's a planet.
No, I don't know about that. There's a Big Bang episode, isn't there, where Neil deGrasse Tyson's in it, and Sheldon's really unhappy with him for demoting Pluto. Totally worth checking out.
I don't like the Big Bang Theory that much. I don't think it's that funny. I'm sorry.
Yeah.
That's controversial.
It is very controversial. People are like, I'm unsubbing now. I've watched some of the Big Bang where they remove the laughter, and it's painful.
It's brilliant.
Oh,
it makes it so much better.
But that's pretty much every sitcom though. Like if you take out the laugh track and there's just like awkward silence, it's just becomes incredibly uncomfortable.
Really does. But yeah.
Anyway,
my girlfriend watches it all the time, but
we should just whenever we have just like a gap in the podcast, just throw in like a laugh track.
Yeah, we should. Laugh track can be supplied by all of us laughing at the same time, and just that's put in.
Sorted.
Anyway, I shall move on. The next major discovery was made in 1916 from the one and only Albert Einstein with his theory of general relativity. He explained that what we perceive as the force of gravity in fact arises from the curvature of space and time, which every time I say that still boggles my mind because it's just really unintuitive. But the reason this has anything to do with the expanding universe is because given Slifer's observations that most celestial bodies are moving away from us, and given the way in which general relativity works, general relativity predicts that upon a time there must have been an incredibly dense state that must have essentially exploded outwards. The thing is that while Einstein recognized this inference from his theory, he didn't endorse it. He instead endorsed what is known as the cosmological constant. A few trivial facts about Einstein that I'm sure you guys know more is that he published his special relativity when he was aged 31. He published his general relativity at the age of 41. When he moved to the United States, the Nazi regime put a $5,000 bounty on his head, wanting him back. And evidently in 1952, the state of Israel offered him the position of president, but he declined.
You never knew that?
Yeah, there's so many like facts about Einstein, and it's hard to know whether or not they're true. But as far as I know, they are true.
Did you hear the one about when he got into an argument with his teacher, and then everyone stood up and clapped?
No, give us this.
Oh god, no! It's like an internet joke where like you know,
Is this the creationist one?
yeah. And so there's always like these stupid like that happened kind of stories, and then there's the one where like they always end with like, and that boy was Albert Einstein.
Yeah, I've seen.
It's so bad because like you hear these wonderful
Einstein
quotes.
will say something like, "Well, well, if God didn't make you, then do you have a brain?" Or it's like there's some like crazy dumb like rhetorical nonsense, and then at the very end they're like, "And that student was Albert Einstein," and it's like, come on, like it's such bullshit because
yeah.
that,
Oh
like,
yeah.
Because like
This
Einstein
reminds me of
he wasn't a Christian.
No, he was perhaps kind of believed in Spinoza's God, which I need to create a video on at some point.
He was more of like a deist, wasn't he?
I guess so, but then
that'd be a stretch. He believed in like order in the universe, and he referred to it kind of as like a God, but he didn't believe in like a physical actual entity that created the universe. Like there were several times when he explicitly said that he didn't. So
on the topic of quotes, it reminds me of one of my favorite quotes from Abraham Lincoln, and that is that you shouldn't trust anything on the internet. So 11 years later, in 1927, I always get this guy's name wrong. Is it Georges Lemaitre? Lemaitre, yeah? Go on, give it to me.
Well, it's French, so like French people don't know how to say R's, and so instead of like Lemaitre, it's like Lemaitre or some gurgly
I've looked online for pronunciations, and I've had several completely different ones. So I just won't say his name again, but he based on the Georges.
Let's call him Georgie.
Okay, Georgie. We'll just screw his name up completely.
Georgie.
Georgie Lemaitre. Based on the aforementioned information, proposed an expanding model of the universe, which he then called the cosmic egg. But the theory was later renamed the Big Bang as a mockery from Fred Hoyle, who was responsible for the competing theory, the steady state. It's a little unfortunate, but understandable, that a lot of people didn't want to pay much attention to George's because he was deeply religious. And so people, men of science, didn't want to listen to someone who was a man of religion primarily because they suspected that he was smuggling in or starting with basically an a priori of religion. And I can understand that, but it is it's an unfortunate thing, but that is the case. There's a couple of things in the history of science that I don't think people should be proud of. We were discussing one with the Piltdown man with human evolution. That's a disgrace. It's not a disgrace on science itself, it's on scientists and the scientific community in general. And I wouldn't call this a disgrace, it's just, I can understand people's skepticism, especially where Einstein had made the same inference but just wasn't committed to it because he thought there must be a cosmological constant. But I was wondering, do you guys happen to know anything about the steady state theory that Fred Hoyle proposed?
I mean, wasn't it just that the universe has always existed in a current steady condition?
Oh, I see. Because I actually don't know much about it. I haven't had the time to delve into what it is, what supported it, and why it's wrong. But I knew that you two might.
The Big Bang Theory basically traces back the trajectory, and I know that you haven't gotten into this yet because I'm assuming you're about to touch on Edwin Hubble. But
yes, yeah.
The steady state basically says instead of it all starting with like one singularity, it's always existed in this current form. Like, there's maybe there's been nuclear fusion happening in stars, and there's been planets that will form and stars that will form in nebulas and stuff. But the steady state tends to view the universe itself as always existing in one form or another.
It's interesting because saying that it always existed in a steady state to me isn't the same as saying that it always existed in one form or another. I was just thinking it might make for a really cool episode to delve into that at some point, especially where it's a scientific theory that's no longer subscribed to. So it would be interesting to know the narrative of why that's the case.
Well, so like the Big Bang tries to explain like the origin of matter itself, whereas with the steady state, it's like, oh, there's always been clouds of hydrogen and helium and all this stuff.
Yeah. So you
So
see, it's interesting because I don't think the Big Bang tries to describe the origin of matter itself at all. I think the Big Bang should be called what George's originally wanted to call it, the cosmic egg, which is to say that this all this information that supports the theory brings it back into this state where it was inside of what we could call an egg for an analogy, but it doesn't say anything about what happened before the egg or um, how the egg got there in the first place.
Yeah, that's what I always thought. Because I always thought like the Big Bang Theory was about kind of, I guess you could say, how the universe got into the state it was in today. I thought it was like, explaining that and how it kind of what kickstarted that rather than like what happened before that moment. Does that make sense? So when people say like, oh, so where does matter come from? Where does this come from? Like, what caused the Big Bang? I'm like, I don't know. That's another theory. That's another thing to think about.
Well, and we run into a problem too, because like, when we look back, when you look up at the stars, you're actually looking back in time. So you see a star that is 5 billion light years away, and you're literally looking at something that has taken 5 billion years for light to travel from the star to your eyes. It's just so distant, and because there's the cosmic speed limit of light itself. And when you have when you're looking at the cosmic microwave background radiation, what you're doing is you're looking back in time, and you're looking at at these microwaves that it's on the light spectrum. So you're looking at light that's taking that long to reach us, but it's not visible light, or not within like the human range of visibility. We're looking into the microwaves. And when you do that and you look back 8 billion years ago when the Big Bang happened, we're able to observe this radiation that from that far back that took that long to get to us, but anything before that we can't see. Like it was just dark. We don't know. Like there's nothing there for us to observe. And so we're we have different predictions, different mathematical predictions, but anything before that is kind of a it's a blank slate. We have no idea.
Yeah, pretty much. One of the pieces of evidence, if you will, that would lend itself to the concept of some form of beginning from nothing would be Einstein's general relativity. But as Sean Carroll's made very clear, we know that it's not right. We know that it's not suitable for super black holes and the beginning of the universe, in the same way that Newton's laws of gravity are perfectly fine on Earth, but they're just not right when you apply it to celestial bodies. It's exactly the same with Einstein's general relativity, and so without that, there really is no reason to believe that things came into existence at that point.
Well, one big issue is like, so right now scientists they've been trying to unite the four forces for a long time. So, for example, just like we once thought that electricity and magnetism were completely separate things, and then we realized that it's actually the same thing. And like if you move like a magnet along a coil, you can like get electricity, and you can magnetize things with electricity. Like we realized that it's just electromagnetism. It's just one thing. And so then scientists have been trying to unite the different forces, and they've gotten into they've ran into some hurdles when trying to unite gravity with electromagnetism and the strong and weak force. And so there's been some different alternatives that have been put forward, like string theory, but then you get into an issue of like you have all these extra dimensions, and it works okay on paper, but it kind of breaks down. And like when you get all the way back to the Big Bang, when the forces were supposedly like united and it was all like one force, then like you start to have stuff that falls apart. And so scientists are still trying to crack this, and I probably completely butchered it just with my layman's interpretation.
I mean, what I got from that is you're basically saying we don't know. Like things are just getting really fucking weird, and I think that's the takeaway from what you were saying, and from what we were just saying.
It's like when we say we don't know, like there's some things that we do know. There's some things that we can measure, that we can test, that we can, unify and we can figure out. And then there's some stuff that it's like we're still working on, and then there's some stuff that like we may never have the tools to figure out. But that doesn't mean that we know the limits of what we can know, and that doesn't mean that we shouldn't explore it.
I always find that frustrating. I find myself saying, it's normally to a theist, I say, I just don't know. And they take that to mean that I don't know anything. It's like, no, we know, we know a lot, but we know a lot about what we don't know a lot about.
I don't know isn't a placeholder for bullshit. Like
Yeah.
You can't just swap it out with like.
No, you can't do that. No, that's an
you say
argument
we
from
don't know
ignorance by
yet,
definition.
You can't just be like, okay, well then therefore it must be like magic. It's like no, like it's probably not that.
It's not. Anyhow, the way I said anyhow there was like I was going to conclude. It was a rationality rules anyhow, but it's not. During the same time, George is not going to mention his second name. During the time he was proposing the cosmic egg, we have the great Edwin Hubble, as you were just mentioning. With the aid of technological advancements, he proved that what Slifer and the world thought were nebulae are actually galaxies, and so he made our vision of the universe significantly bigger. Because imagine looking for years at like a certain blob of stars or a certain blob and just thinking that's one star or maybe several, and then realizing with a few more inferences that it's billions of stars that form an entire galaxy, and then realizing that so's that one over there and so's that one over there. I think that's one of the major points where we really must have thought we are really, really insignificant.
It really shifts your perspective, doesn't it?
It does.
Not just inferences, though. Like, we actually have higher resolution telescopes that,
Yes, that is very, very true. But yeah, to me, that I find that crushing to some extent. My ego gets destroyed by such observations, but my my sense of adventure and my many of the values I hold that aren't about just egoism are absolutely blown away by that fact.
But it's amazing. I find it quite freeing though, because like when I don't have anxious brain and I'm like rational me, and then you realize that like as an individual I don't actually mean that much, and like no one's really gonna care if I wear a top that looks a bit silly one day, or in the grand scheme of things, no one's gonna care if I wear blue eyeshadow instead of pink one day. And so it means that like all the stupid little things that you normally worry about really don't matter that much. And if you want to spend your time reading trashy romance books instead of like intense books on physics and chemistry, like that's fine to do as well, because really, what's it matter? I don't know. I know it's a really stupid thing to say, but it just, I don't know, it seems quite freeing to me, the fact that it doesn't really matter that much. Might as well have fun.
I see this. Yeah, go on, Thomas.
I was gonna say one of my favorite memes. It has like two different perspectives on life, and one of them says like, you see this guy and he's like super depressed and he's like moping and he says nobody cares, and then you see like another one where the guy is like nobody cares, woohoo, and it's like when you think
like my two states of being.
Yeah, it's like on the one hand, you could come away from this thinking like, oh, this universe is just so massive. What's my purpose? There's no real meaning, and like there's no like fatherly like figure or Earth Mother or divine supernatural thing that like gives a damn about me. But at the same time, it's kind of liberating because you're like, I get to like go out and find meaning in life and do awesome things and have fun, and not be just judged and treated like, I'm having to live up to like a certain standard or expectation that maybe isn't necessarily what you want with your life. You don't want to grovel and worship. And at the same time, you're free to do the things that matter to you.
Yeah.
So it's kind of liberating.
And I would add as well, actually, more so to Rachel's point on the fact that sometimes, or in the past, I felt bad about playing video games rather than working, or whatever it might be, rather than pursuing an intellectual goal. And that was reinforced by people telling me that I ought to be doing the more intellectual, stimulating things. But this completely ignores the fact that I'm human, that we're human. We have to recharge, and we have an element where we have to enjoy our lives, and this is where fulfillment of those needs can come in. I very much enjoy gaming, and if that's what recharges my intellectual desires, then so be it. It's just the way it is.
Yeah.
But slightly move on, but to stay with Hubble. In 1929, he published what is now known as Hubble's law, which states that celestial bodies rushing away from us are doing so at a speed directly proportionate to their distance. And so a galaxy that is twice as far away as us, a galaxy that is twice as far away as another is receding twice as fast, while a galaxy that's 10 times as far away is receding 10 times as fast, etc. And thus he proved that the universe is expanding, which is, needless to say, an extraordinary find. That's huge, and of course it very much supports the current Big Bang model. Just a bit of trivia for you quickly is that it was this discovery that caused Einstein to abandon his cosmological constant. Einstein personally thanked Hubble. And a little fun fact about Hubble himself, and you can kind of tell from the photos, is that he was a gifted athlete. He stood out in basketball, football, baseball, and boxing, and he once knocked out a German boxing champion.
Kind of puts us to shame, doesn't he?
I know, it's like, come on, man! Like, have intellect or be muscular. Don't have both, you bastard. But no, good on him.
Can I point out real quick, like when scientists make these predictions too, they're looking at a macro scale, so they're looking at like, you know, a massive number of galaxies and getting, you know, an accurate prediction. But you're gonna have some outliers that are, for example, like we've got the Andromeda Galaxy, which is actually moving towards our own, but that's because it's within such close proximity to the Milky Way that it's able to feel the effects of our gravity, and it counteracts the expansion of the universe itself. And so, like within galaxies themselves, you know, they have this cluster. The stars within the galaxies aren't moving away from each other. They're all, you know, caught within this gravitational well, you know, that's usually like at the center of the galaxy itself, whether it's like a supermassive black hole or whatever. But when you start looking like outside of that and you start looking much bigger, like the distances between galaxies are absolutely just gigantic, mind-numbingly huge, that, you know, that you start to see all of these effects. You start to see the universe itself expanding. So they're not just looking at like one little pocket. It's not that every single star is moving away from every other star. It's like all of these galaxies, you know, they're far enough away that like you can see that they're all moving away from each other. Like the universe itself is expanding out.
On that sheer scale that you were mentioning there, I remember recently reading, forgive me, this isn't going to be exact, that our top speeds are very, very slow compared to the speed of light. And the fastest we've ever made anything is by exploiting the sun's gravity. But even with the fastest we've ever done, it would take 6,000 years to get to the nearest sun other than our own, or the nearest star. And if you actually figure out the distances between the planets that we know of in our solar system, it's mental. It's so much bigger than you think. Like the distance between Earth and the Moon, and Earth and Mars, I don't know the exacts. I can't even give you an estimate, but it's worth looking up. It's so much bigger than you think. But before we move on, go on.
Just I think a kind of a good visual analogy that I just thought of, like to what I'm thinking, is like if you think of like a balloon, and the balloon itself is like being blown up, and like so the surface, like the outside of the balloon is like the surface area is increasing. But if you have like one little drop of water on the top, that like let's say that it doesn't like trickle down, or it doesn't like, you know, fall down due to gravity, but like let's say that it's just resting on the top of the balloon, and the balloon expands out, the surface area expands out, that little drop of water, it's still going to be held together through hydrogen bonds. And so it's like the drop itself isn't going to grow at the same rate as the balloon.
Like
it's
it.
going to be locked into, you know, in the same position. And that's kind of what's happening with like most galaxies versus the universe itself expanding.
That's a great analogy.
I like that.
I assume what you're saying there is that the balloon surface area expanding is the universe, and the molecules sticking together through the process that you said is gravity.
Yeah, it would be like stars held together by gravity.
Yes, I like the analogy. You should do more with it.
I think that is something that, like, people tend to forget when we talk about these big theories and stuff. It's that, okay, we can talk about like the universe expanding and stuff, but that doesn't suddenly mean that all the other kind of theories in physics stop existing, if that makes sense.
Yeah.
Like, it's within that, gravity is still going to have a force, and this is still going to have a force, and so on. So, yeah. No, I like that analogy, and I think it's a good one for reminding people that, you know, there's more than one force acting on something at a time, if that makes sense.
Yeah.
I don't know. I don't know enough of, like, the actual technical, like, terms in physics to express myself well here. I feel like I'm just rambling a bit.
No, but it's a really good point, though, because, like, it's that these theories don't exist in a bubble. Like, we have to calculate all of it in.
It's a better way of saying
time.
it.
It's just some of them have stronger effects than others, and some of them only apply at certain scales. Like the strong and weak force only apply to like the super, super small. You know, anything bigger than an atom isn't really gonna feel its effects. It's not gonna be noticeable at all.
Yeah.
And so you can't, you know, physicists aren't calculating in like, oh well, the universe is expanding, but have we taken into account the strong force? You know, they don't think in terms of that. They're like, all right, well, we have to think like these things are absolutely massive. Like they have a strong gravitational pull, but the universe is like so huge and they're so far away that like the effects of gravity on this scale are pretty much negligible. Like, you know, they have to think about all of it, but there are certain scales that some stuff applies and other things don't.
Great points there for sure. That's going to be a short, I'm sure. Okay, so I'm going to move us forward. The next breakthrough came in 1932 with Carl Jansky, who, while investigating static interference with shortwave transatlantic voice transmissions, accidentally discovered radiation emanating from the center of the Milky Way, indicating that everything within the Milky Way once coalesced. I find that's great. Well, it's one of the most important discoveries we've made in one of the most important fields, and it was made by an accident.
I love stories like that where someone's just like trying to do something that's like quite important, and you know, and then they just figure out something that is literally life changing.
It is.
I love it.
Like they thought that their scanners were broken, and then they thought that there was like bird poop or something that was like affecting it.
It's funny, but all of that comes later with people that were building on top of his observations. And but Carl Jansky himself, if you actually look online at what he used to do these tests, as it were, it wasn't subject to those kind of problems. But the people that came afterwards, yes, there was one where they spent an entire year trying to figure out where the hell is this coming from.
Yeah.
And they just could not figure it out. It was pretty damn amazing.
Well, and they kept like they would move into like remote isolated places. They would point their scanners up like all throughout the sky, and like everywhere that they pointed it, they were getting the same, you know, radiation.
Yep.
And then they like I think they tried detecting it in outer space and they still got it and stuff. It's like that's the thing about science is like you don't just make speculation. It's like you have observations and you're like, whoa, what is this? Like this doesn't make sense. Like and then you try to figure it out, and you know.
Yeah, well, actually, on that note, I'll push us in that direction. And this discovery didn't come until 1963, so 30 years after Jansky's finding of the center of the Milky Way emanating radiation. But it was when a person called, actually, it was one person, a person called Robert Dicke, who was inspired by Jansky, theorized that if galaxies emanated radiation and almost all galaxies are moving away from each other, then perhaps the universe itself is emanating radiation. And this prediction was proven by two people, one called Arno Penzias and one called Robert Wilson. But something that blows my mind about this, and it must just be my privileged position of now knowing this information, but I can't believe it took 30 years for someone to make this inference, for someone to predict that. Like, to me, that is so obvious. If you already know that everything's expanding away from each other, and you know that stars within galaxies themselves are expanding, and you happen to find radiation in the galaxy, I think it's easy to say, let's at least suspect that there's just a radiation in general coming from the universe, which is the radiation that you were just talking about. They tried their best to remove any kind of interferences, and they just found that the universe just has a radiation. Yeah,
how well the who was it that discovered the radiation at the center of the galaxy?
Center of the galaxy was Jansky.
How well known was Jansky's discovery?
it might be a good question, considering it was an accident.
Mhm.
The
Because
ultimate answer.
oftentimes, and I'm saying this, I have no idea. It could have been, a huge breakthrough. So don't quote me on this, but oftentimes, like, I'll see scientific discoveries that, like, in retrospect, we're like, oh, so and so discovered this on this date, but sometimes
Mhm.
it'll go like 20 years before someone like actually realizes the significance of it, and it like breaks through, like the scientific community becomes
Yeah.
aware of it. If he didn't
Yeah.
publish it anywhere and it didn't really gain any kind of traction or get noticed, then it might have just kind of been percolating in the background and not.
I really do think we should dedicate an entire episode to that, because I have more and more, when looking into the research and history of certain scientific discoveries, they are exactly as you just said. They're not accepted by the scientific community immediately, even though their evidence is overwhelming in some cases.
Or even
Um,
known. Like
yeah, I know,
Mendelian
not even known.
genetics,
Yeah,
like Mendel did his work and it
Mm.
basically sat in like a vault, not a vault, but like in
yeah.
storage, and then someone stumbled across it and they're like, oh wow, the implications of this.
It is bizarre, but you're totally right. This happens far too often. And I'm just thinking of another. You also get this with authors and philosophers, for example. Um, we have it with Marcus Aurelius. People didn't really
Mm.
realize the significance of what he was saying, but the one that comes to mind is Hume and his first book. It made nothing. It was rejected. It was basically it was off the shelf
Mm.
within a couple of months. It wasn't important at all. That's now his most important work, and people recognize it for being absolutely brilliant. But at the time, it was nothing.
Well,
So it's amazing.
artists as well. Like Van Gogh was
Yeah,
ridiculed in his time. Now
yeah,
he's
it's
seen as like
true.
one of the most talented artists out there for his use of color and texture and pattern and just the way he saw the world. But
Well, to be fair, didn't he bite an ear off or something?
no, that
That's
was
Mike Tyson.
Picasso, I think, wasn't it? Who cut his
No,
ear
I'm
off?
pretty sure. I'm pretty sure that he had like he tore his own ear off or he did something like.
Van Gogh was like, he had a lot of mental health problems and he suffered a lot with depression and possibly bipolar. I don't know.
Yeah.
And he had problems with alcohol abuse as well. So people didn't really take him seriously and they didn't really get his work at the time. It was only years later
Yeah, it says
that
that he's
we
known
kind of
as
discovered it.
the tortured genius who cut his own ear off.
Oh, I didn't realize that was
Wow,
him.
that's
Yeah.
crazy.
I don't know if that's apocryphal or like if it's actually true, but
Yeah. But this does lead me to a question, right? Is it better that we are more skeptical, or we don't just accept these like big life kind of, or science changing discoveries straight away, and we're a bit more skeptical? Is it better that we do that than we just kind of like accept everything straight away, even when there might not be as much proof? Do you know what I mean? Okay, I'm not.
Yeah.
Words.
No, I absolutely do know what you mean.
Yeah.
I think you're right.
Like, is it better that things are set back for 10 years because we are kind of trying to find more proof, or we're trying to be a bit more skeptical about it? Or is it better that things are set back 10 years because we accept something as being true when it's not, and we're going down the wrong path? Like,
I think the latter. I think you're onto something there. It is, and it's just more akin to the scientific method as a whole. It's just the way it's going to work. And the more I'm thinking about it, this is the way it works. There's a wonderful clip on YouTube from Fred Hoyle, who was a very controversial figure, not only because he maintained that the steady state is true despite the discoveries we've just mentioned, but because of his position on science in general. And to me, it spoke to me. I thought that he really was onto something, and he was mentioning some of the things you were saying there, and some of the hidden dogma that is in scientists, not in science, but in science, especially under a democratic regime, a democratic situation, which you don't see in regimes where the aristocrats say, "I don't care what you're saying. Do this research. I will fund it." But that's something I'll link in the description because it's a little far removed. I do have a very interesting question for you. A question that,
can I real quick chime in on that note?
Yeah, of course.
I think that there's, on the one hand, there's a balance where you don't want to just accept every new proposition and theory that's thrown out just as like, oh hey, yeah, this has just as much legitimacy as everything else, because quite frankly, extraordinary claims do require extraordinary evidence. But if you have a scientific theory that's put forth, well, or a hypothesis that's put forth that is able to, accurately describe, what it's predicting, how it works. It's able to give a mathematical model, and it has evidence that it fits, and it's not disproven by any other field of evidence or any other field of science or any other evidence that we've gathered, then it's like, yeah, I think it should be accepted. And for the most part, it usually is. It's just if there's an equally viable theory that hasn't been disproven, then what happens is you have two competing theories at once. And there's a lot of fields where this will happen, where we don't necessarily know exactly how something works, and we'll have competing theories until one of them is disproven. But I don't think that scientists should be in the business of just rushing into and accepting everything, but they should be into the business of accepting everything that we have evidence for.
Yeah,
yeah,
that's a good
that seems
point.
fair.
And just to give an example of what you were saying, I think quantum mechanics very much falls into that purview at the present. There's many theories, and they're just having to compete because we don't have enough tangible facts or observations in order to rule one or all of them out. So a question I have for you, this is something I haven't considered much because for most of my life it hasn't bothered me, but the more I'm thinking about it recently, it is bothering me, and I will probably create a video for rationality rules where I really do respond to it. But why is there something rather than nothing in the grand universe? It's a hard question. I do appreciate it, and that was a perfect silence for us to have laughter from the Big Bang. In fact, I'm gonna put it in.
Just a random laugh track in the middle of it.
Hey, just out of nowhere. But why is there something rather
Should
than
I be
nothing?
like
Is
the
this a
dumb
question
blonde girl
that
like
you've-
Penny and go, duh, because lip gloss? Or something
That's a
equally
good
like...
answer.
you
Good
know.
answer. Yes. Well, I thought that Tom would be the dumb blonde, but
I don't know that that's even a legitimate question. Like, I think that the question is, how is there something rather than nothing? Because why implies that like there's some type of purpose behind it. I don't think that that's necessarily the case. Like,
the
I think
why just makes me want to ask why not. You know, like why wouldn't there be something? If that makes sense.
to me, it reminds me of a speech that Douglas Adam gave, and I don't want to butcher it, but I do want to present it in a shorter way. He essentially said, imagine if a puddle woke up and it was able to investigate things around them, or around it. It would go, look, I'm in a perfect hole for me to form, and there's a perfect amount of water and a perfect amount of sunshine and a perfect amount of X, Y, and Z. This has to be created with some purpose, and it's probably got me in mind. We used to be the puddle. Some of us still are, unfortunately, and I would put the religious in that bag. But many of us have figured out we're not the hole doesn't exist for us. We've evolved to be in that hole, and
that's
the way
I was gonna say the very end of that you left out.
Yeah,
it's from the Salmon of Doubt. By Douglas Adams, and it says, and he continues pondering that until the sun evaporates.
Yes, and that may well be the case with many of us. Luckily, as I was saying, many of us have realised that the world isn't here so that us, the puddle, can exist. It's the other way round, and the questions such as why does the whole exist in the first place may be just as redundant as us thinking why is the universe created with us in mind. It might be a question like what colour is jealousy? It's a category error. It's a mistake. Yeah. It's a question that's unjustified. It might be, as Bertrand Russell said, a brute fact, just something that just is. We have to just work with it. But I find it to be a very interesting question.
It could just be a statistical inevitability. Like if there are more than one universe, if there's more than one universe, or it could be that our universe itself has been adapting and changing and morphing over time, and that,
But I guess you could still say whatever it might end up being, a multiverse, or, as you're saying about Hawkins' hypotheses or theories, whatever it is, why is there anything at all rather than nothing? It seems intuitively to be a good question.
To quote Jordan Peterson, what do you mean by anything? What is something?
How do
you define nothing?
That's a much better question than you
How do you
expect.
define enough? And is a much better question. In fact, it's such a good question that Jordan Peterson wouldn't say it. He would say, "How do you define it?"
Yeah.
So it's funny with the Jordan Peterson
How do you
scenario.
define?
Yeah, I've had a lot of people message me saying, "What was your thoughts with the event that happened in London?" Because a lot of people saw me there. By the way, if I saw you there, it was a pleasure to see you. But I felt that Sam Harris just nailed him to the point that it's over. And I haven't listened to anything Jordan said for about a month now, and I feel like my sanity's coming back.
So I feel like I'm a little behind with Jordan Peterson. Like, a lot of people have been asking me to comment on him, so I finally decided to like read his book, and I'm going to do one of my like in-depth reviews on it on my channel. And oh my god, there's some crap in there.
Oh, there is.
God.
I felt for the longest time so alone because the entire skeptical community was basically sucking his dick.
I decided...
And I just thought, this is ridiculous. Like, this is nonsense.
There's some really deep positive things in there, like make your bed.
The thing is about Jordan Peterson, there is there's many things that he touches on. The way in which he addresses them are great. It's very insightful. The problem is that people equate that with what nonsense he's saying in philosophy and
the other problem
religion.
I have with him as well is that some of his science is just wrong. Like at one point he literally tries to say that a lobster's brain dissolves and it grows a new one, and I'm like, for one, lobsters don't have brains, and for two, you don't just dissolve your nervous system and grow a new one because you lost a fight. Like, there is no proof out there that could ever happen to a lobster or anyone else.
Even if that's the case, like the extrapolations that he then makes to compare that with human anatomy and to, it's like you just can't go there. You can't. It's such a stretch.
Yeah.
And the thing is, like, his point in that chapter about talking about how like serotonin has an effect on our mood and how we see ourselves in the world, that's great stuff. Everything else is crap.
Well, the best lie is 99% truth. And I find that that's something that happens a lot. But I've had Jordan Peterson hijack my channel for several months. I'm not having him hijack this podcast, so we're done with him now.
But Steve, what do you mean by hijack?
Don't, Rachel. Don't do this.
It's like, now what do you mean by Big Bang?
What do you mean by podcast?
The thing is, I find myself sometimes having to say, well, what do you mean by this? And I've had people go, well, who's now doing a Jordan Peterson? And I have to go, no, he's not. This is not the same. He just uses a new definition of cup and doesn't tell you that he's using a new definition of cup for about several months, and then he will tell you. And it's like, that is not the same as saying, this is a difficult word. What do you mean?
There's a difference between that and wanting to be like on the same page as someone you're debating to, understand their terms and how they're using them.
Yes, exactly. And that's just, you're practicing Voltaire's great advice of if you wish to converse with me, define your terms. That's fine. It just gets weird when you want to redefine the word you. So I have two more questions.
Yeah,
the first
sorry
is
for that.
no, it's great fun. I jest. I'm being facetious. But first question is, do you think we'll ever have a theory of everything?
Oh.
I want to say yes, but I don't think that it's necessarily anything that we expect it to be.
I think, and this is going to sound really douchey, but I think theoretically it's possible, but practically maybe not. Do you know what I mean?
No.
Okay, so like again, I'm trying to say this without it sounding really douchey. I think it's possible that we will be able to, I think it's possible that we would be able to find evidence for enough things and come up with theories for them and so on and so on. But practically, I'm not sure if we'd ever have like the time and the expertise and stuff to do that. So I think it's possible, but it might not be probable.
Okay, so when I say, do you think we'll ever discover the theory, your answer is no, but it's not because it's not possible. It's just you just don't think the resources and the time and whatnot will go into it.
Because
that's cool.
As time goes on, there's probably going to be even more and more to discover, and like not everyone is gonna like spend 100% of their time working on discovering this stuff, you know? People
Here's a
wanna
question
play
though,
games.
Rachel.
Mhm.
So even like let's say that humanity works on this problem for the next 1,000 years, and we have more scientists, better tools, augmented intelligence connected to the internet. We get like super intelligent, but right before we discover the how everything in life and the universe and everything works, we get wiped out by an asteroid. If that's the case, obviously we didn't discover it, but do you think that some life out there in the universe that is like it's possible to, like you said, it's possible to discover it, maybe there's like some extraterrestrial intelligence that's way higher, advanced than our own. Do you think that like it will be discovered? And I know it's pure speculation.
Yeah, I honestly don't know, to be honest. Like, I think, like I say, given enough time and will, and with the right tools and stuff like that, like, I think it is possible to find evidence for all that stuff, but whether anyone will is a different story, so I'm honestly not sure.
For me,
I'd like to think yes, but
I don't think we will.
Really?
And it's because there's certain observations, such as what information we do know about the universe. If we was to make those same observations in millions of years to come, because of the expanding nature, we wouldn't see any other galaxies. We would only see our own, which means that there is no way we have any access to information that is required to know that the Big Bang happened, let alone that at least I'm sure you get what I'm saying, let alone what happened before the Big Bang. I personally suspect, although I don't operate this way, I suspect that if it's not where the Big Bang happened, but it's somewhere slightly past that there's an area where the facts of the matter are just not accessible to us in the same way as we won't be able to observe other galaxies if we was to look at them in I think it's billions of years to come.
But do you not think by that point maybe like we will have the tools to be able to observe it and look at it, whether it's like, bigger telescopes or other equipment or things that can detect whatever?
I think the right answer would be, for me personally, is that I just personally suspect we will never be able to go past these certain laws of the universe that we inhabit. So, for example, as a macroscopic entity, we are not going to be able to travel faster than the speed of light. That may not be the case.
Necessarily true, though, Steve.
Yes, I know, because you have the concepts with the expansion of space and whether or not we can utilize that via wormholes, etc. I see no evidence for it. So what I'm saying, to be clear, is that I'm not 100% convinced either way. It's just if you said to me, where do I personally fall? I personally think that we're not going to figure out a theory of everything. But that isn't to say that we shouldn't try.
Well, what I was gonna say is like, just because so what Steve what or Rachel what Steve is when he was saying like we wouldn't be able to see the universe, it's because these galaxies are speeding up and they're getting they're going faster and faster. Eventually, they're gonna reach a point where they're moving faster than the light that's getting to us, and so like we won't be able to see anything anymore. Like they're gonna be outside of the visible universe. And
it's not only see though, we won't be able to detect them.
Yes. Well, because light is the fastest thing that's traveling towards us. We detect it in terms of light, whether infrared or ultraviolet or visible, But where I think that we're not necessarily gonna have to worry about that is, one, we're not talking millions of years out, we're talking billions of years out, so we have a lot of time to still make these discoveries.
No, okay, I've got to be really clear here in the sense that the reason I use that as an example is because if we say that in 6 billion years, if you accept the premise that we won't be able to discover what we already know because of those 6 billion years time of space expanding, etc., what I'm saying is that there may be an enormous amount of time before our Earth, which of course there was, where we've already lost access to key information that is important to the theory of everything, and thus we're just never going to know. Does that make more sense for me to put it that way, or?
I guess, but the theory of everything, like I don't like. it's
I
kind
mean,
of like
I have
you
pulled a
when you
big one on
observe
you here.
when you measure, you know, like the strong and the weak force and gravity and electromagnetism and stuff, like none of this is predicated on understanding what happened before the Big Bang. Like we can still measure these
Some
forces and see how all these particles interact and see how they break down at different temperatures, different speeds. You know, we can go observe the radiation all the way back to the Big Bang. Will we know what happened before it? I think that's unlikely. But will we be able to actually have a theory of everything and unify the forces? I just think that comes down to like, were they ever unified in the first place? And if so, then I don't see any reason why we wouldn't eventually be able to discover exactly how it works.
To me, that would mean defining everything as our observable universe, whereas that's not everything. By a theory of everything, I mean everything, understanding everything, or having a theory of everything. Whereas I think that we already have a theory of our observable universe. That's fine. I've got no
But
problem with
a
that.
theory of
It's the
theory of
further.
everything, when scientists refer to a theory of everything, they're just talking about the unification of the four forces. Am I right? Like
That's an interesting point you put there. You may be correct. I'm going to Google it because if that is the case, then I'm just
So are
using
you
the wrong
guys asking
terms.
how do we define everything?
Essentially, yeah. Pretty much, Jordan.
Because the four forces are basically like that's all that there is when it comes to the interaction of, you know, particles and matter, you know, with other
It says
stuff.
a theory of
With other matter.
everything, or final theory, ultimate theory, or master theory is a hypothetical, single, all-encompassing, coherent theoretical framework of physics that fully explains the links together all physical aspects of the universe. You could look at that in several ways, but I have dropped a big
They
question
call
on
it
you here, and it's
they call it the grand unified theory because it's the unification of the four forces.
You may be right. I totally may be using the wrong term, but you get what I'm saying about understanding everything.
Okay,
Yeah.
I have one last question. And like when I ask this, like this doesn't mean anything about my personal opinion, but do you think understanding how the universe started and, you know, spending even more time trying to figure it out and trying to prove the Big Bang more or less or disprove it or whatever, do you think it really matters in the grand scheme of things?
Not really,
Yes. In the grand scheme of things, because it may determine whether or not we can reverse entropy and live forever trillions of years after we're probably all three of us are dead.
I think as far as our purpose in life, that we define ourselves, the most fundamental aspects of our being, it doesn't matter. But as far as how it can help us, as Thomas was just saying, yeah, it absolutely can, because it may looking for how the universe began may unlock how exactly we can have perpetual energy, if it's possible at all, etc. So it's worth doing. It's a fantastic endeavor, but I don't think it matters in order for you to be fulfilled, to self-actualize, if that makes sense.
Yeah. Well, and it's quite possible, you know, we haven't even looked into in this episode the multiverse theory. We should do an entire episode on that. But there's one of the theories put forth by Lee Smolin is the this idea that our universe is designed to make black holes because there's more black holes than anything else. And what if every single black hole is giving birth to new universes that are better selected for making black holes? And life is just kind of a byproduct. You know, but if that's the case, like
I could see that.
You know, whether it's for black holes or not, like, if you have multiple universes and they all have, you know, or if there's an infinite number of them, then we're having this conversation in another universe where Steve's hair is red, and that's the only difference between that and our own, just because there's an infinite number of possibilities.
Yeah.
Damn it. Why couldn't I be born in the universe where I'm a natural brunette? Why?
Actually, you probably are.
But then what do you mean by you? Okay, we're done. If there's anything I want to stress with this video is that of all the discoveries that have been mentioned, and of the many more, none of them say that the universe came from nothing. If like look them up and see whether or not you get that inference. I don't think you can. It's possible that that's the case, but they don't assert that must be the case, and that's basically the point I wanted to get across. The cosmic egg, as first stated by Georges, is, in my opinion, the best term to call it, and the Big Bang, because it was meant as a derogatory term, has actually caused a derogatory situation. So I want to end with a quote from Brian Greene, and that is that when we speak of the Big Bang, we often have an image of a kind of cosmic explosion that created our universe and sent space rushing outwards. But there's a little secret. The Big Bang leaves out something pretty important: the bang. It tells us how the universe evolved after the bang, but gives us no insight into what would have powered the bang itself. And finally, I'd like to say that please join us next week, where I don't know who's going to be doing what or saying what or what topics. So
can I say something to ruin the entire podcast?
Oh God.
Do it.
And this comes from like Sean Carroll and like Minute Physics and stuff, but like the whole notion of the Big Bang is a complete misnomer. Like it'd be more accurate to call it the everywhere stretch model.
Yeah,
it's like all of the universe is like stretching out at once. It's not just there was one point.
Mm-hmm.
It's like the entire universe used to be really hot and condensed, but it's like it just all started stretching at once. Like it's not. I don't know if that makes sense.
Mm-hmm.
No, it does. Yeah.
Yeah.
It's a bad name, and you would expect that because it was meant to be a bad name. So.
Yeah.
This has been an absolute blast, and now we want you to join in the conversation over on the Here and How Facebook and Twitter pages, or follow us on Pinterest and Instagram if you just want some of the dankest of sciencey memes. If you like one of our particular styles, check out each of our YouTube channels: Rachel Oates, Rationality Rules by Stephen Woodford, and Holy Kool-Aid by me, Thomas Westbrook. To find all of our episodes, show notes, contact information, and more, warp on over to our home base, thehereandhow.com. If you enjoyed this episode and want us to succeed in spreading the love of science, you can help us out by giving us a 5-star review on iTunes or Stitcher. And to all our friends and family listening, thank you for spending this episode with us. We'll be back to explore another exciting big idea next week. Now go create something magnificent.